Okay. All right. I hope this is the last installment in this video presentation of Chapter 6. I believe it is the time value of money chapters. More complex annuities. We've been, if you thought the annuities problems and examples we were going through were complex enough, guess what? We've got even some more complex ones to go through. Now let's see what this is all about. First, we're going to talk about an annuity that's deferred. We want to do an annuity, but we're holding off the start of it. So we want to figure out the time value of money part of it. Let's see what happens here. This is a type of annuity contract that delays the payments to the investor until the investor says, go ahead and start paying me. When that happens, they do their investment. And so we're saying that the investment grows and compounds in a tax-deferred manner. Investors paying no tax on the growth until he decides to convert the investment into an annuity and start receiving regular payments. Well, I don't know what any of that means, but we'll know better when we see an example. So let's see, doing the future value of a deferred annuity. Let's see what that's all about. It's going to sound complex, but actually some of these are very easy to solve for. And what we're really doing, before we take a look at the example, so let's go back one, what we're really going to be doing is combining everything we've learned up to this point when we get to these complex annuities. We're going to be combining the simple sum calculations of future value versus present value and combining doing annuity calculations with the questions that come up. So let's see. 2013, this company starts planning for a major expansion 6 years hence. At the end of 2016, notice the word end, so that would mean to you, you should be able to say this now, have that reaction in, say, your kneecap, which would jingle, and you would say, oh, this must mean that we're looking at an ordinary annuity because it's at the end of the period. And at the end of 2016, 17, 18, they reckon. I like that word. Penway reckons. Man, sometimes these things go a little funny, but they reckon that they'll be able to invest $50,000 a year. That's the annuity. And they're going to earn 5%. How much will this company have to play with when it starts its expansion? So this is a future value question. How much money will be there in 2019? To solve for this, we go back to what's called figure 18 in this presentation to see that for 3 years, because that's what we were looking at here, 3 years, 16, 17, 18, the ordinary annuity factor is this. So let's take a look at this number and let's go back to the table. This is going to take a few slides back. Here it is. What did we say the interest rate was going to be? 4%? Or 5%. Oh, that's good that I forgot. But it's for 3 years, and here's the 4% and 5%. So let's just take a look, and then we'll go back and see which one it is. You may remember, I don't, but we got these interest rates coming up. So it's one of these two, and we'll go back and see which one it turns out to be. This is fun. If this isn't going to get you nauseous, I don't know what does. So we're trying. Okay, so here is the 3.152, and it was for 5%. And you can see it's a recognized number from what we just looked at. That's the factor that we use starting in the year 2016. So we meant simply, at this point, it's simply multiplying that factor for 3 years for the $50,000, and it'll be a future value annuity at the year 2019 of this amount. Basically, because we've deferred 4 years, it doesn't change the calculation, even though the problem says we're not going to start the annuity for 4 years. We're going to start the annuity after 4 years, because 13 we're not going to do it, 14 we're not going to do it, 15 we're not going to do it. So I guess it's not 4 years, it's a 3-year deferral, actually to the end of 16, so it's a 4-year deferral. It's 2013 we don't do it, 14 we don't do it, 15 we don't do it. Even though 16 we don't do it, the ordinary annuity doesn't start until the end of 16. So what does 3 years starting at the end of 16 start to do? It's just simply do the annuity factor at that point for 3 years. How about the present value of a deferred? So this wasn't too complicated, by the way. Basically ignoring the years that you're not putting any money away because nothing's growing. It sounded a little complex, but it's not. Present value of a deferred annuity. Let's see how this works. This can get fun. So this is now present value. And here we're going to look at this and understand what's being calculated. There's this Dottie character who's going to make an annual payment of $3,000 a year. We're told it's an ordinary annuity here. And what she's doing is she's going to defer 3 years of making the payment and then make 3 annual payments. So it'll be 4 years of not paying it and 3 years of paying it. What's the present value of doing that in the future? What is it that you would need to set aside today to be able to make these payments? This particular issue, just to give you a bird's eye view of how practical this is, this works pretty good when we're trying to figure out what somebody needs today in savings in order to make the retirement account, knowing that they're not going to draw on their retirement account for another 4 years or 40 years, depending on the age of the individual we're talking to. Okay, so now we have, to calculate this, what we do is first we do a present value of an ordinary annuity as if it's for 7 periods, 7 total periods, 4 of the deferred period plus the 3 real ones. The factor that comes from the table is this factor. So that's as if we made $3,000 a year of an ordinary annuity for 7 years. Then we subtract from that the factor for 4 years, because we're not actually doing 4 years. The net result here gives us the factor for the deferred plus the 3 years we're going to do. Let's say that again in a way that maybe I can explain it, that I can even understand what I just said. First, we figure out what would it be if we were actually making $3,000 a year payment for 7 years. Okay, that's the factor we would use, the first factor here, this one. Then we figure out, okay, for 4 years we're not actually doing it, so take this out. Take the 4-year deferred from the table out of this number, take it out, and that's this number here, because that's what it would have been for 4 periods. The result leaves you with the 3 years you're actually going to do it, and calculates what we want, which is the 3 years we actually do it after deferring it for 4 years. Does that make sense? Oh, it makes great sense. Like I know what I'm talking about. All right, I think it makes sense to you all. We'll talk about this in class when we get back. Long-term bond valuation, let's just see a little bit here. Penway Inc. issues $200,000 of 5% bonds on January 1. They're due in 3 years. And they pay interest annually. So here interest is going to come out. That's an annuity. Interest is going to be paid. To figure the present value of the principal amount of $200,000, multiply $200,000 by the present value figure from the present value table, which we can get from figure 4. So let's go back and see that. This is the factor, so let's look for that number. I don't know if we have table 8.4 here, but we'll find out in a minute. There's 8.5. There's 8.4. So here we see this is the present value table. That's what we're trying to figure out. And the interest, it was for, I needed to know other factors. I think it was for 3 years. Does that sound right at 5%? Does that look like the right number? Well, we'll go back and find out. 86384. So that would be the present value of what we need today to pay out over a certain period of time. So let's go back and see. Half the battle is knowing what table to look at. All right, there it is. That's the number. So that's coming from the present value of an annuity table how much do you need today to pay out the interest rate of 3 periods and 5% on $200,000. So the present value to pay out the required interest over the 3 years is $172,768. Then to find the present value of the annual interest payments of $10,000, you do the same thing, and you wind up with a present value of the $10,000 that's getting paid out at $27,232. And the result of all that is it adds up. Oops, what happened there? It adds up if you take the addition of $27,232 plus this number, $172,768. And I'll explain this again. If you add these together, you will get $200,000. This is an exercise in futility because the answer was pretty clear right from the get-go, but this is just showing you how it all fits together. So let's explain it. Put down $200,000 at 5%. Obviously, that's the present value to pay out the $10,000 over the next 3 years and to pay the $200,000 out at the end of the 3-year period. That's what we need to pay it out. So to prove it, what's the present value of the principal that will be paid out 3 years from now at 5%? It's $176. So if we put down this amount to pay 3 years from now, the present value to pay $200,000 3 years from now at 5% is $172,768. I see what we're doing. And the present value of the annuities for $10,000 over 3 years is $27,232. Together they add up to the $200,000, and it just proves that these tables do work. This problem is better described the following way. Pardon my voice. It's better described the following way, that to solve problems, sometimes we combine doing the present value of a single sum and an annuity, and that's what we did here. First, we did the single sum, which was, what do we need today, that means present value, to pay $200,000 3 years from now at 5%. We solved for that. Let's make this look a little bit better. 3 years. We solved for that. That was 172 approximately. So that allows us to pay $200 3 years from now. In 3 years. Then we solved, what do we need to have today, present value, to pay $10K as an annuity. So now we've combined a single sum with an annuity. We just add them together, and that's what this problem is trying to show you. You can do it just by adding them together. And when you took this number, this present value, and added it in to the present value found over here, it came out to the exact amount of the bond, $200,000. Again, that was self-evident from the beginning, but the problem illustrates how it all works. Okay, we went beyond the normal amount of time, but that completes, for the most part, absent a in-class summarization and final points on the chapter as a whole, Chapter 6.